Hello everybody, welcome into another lesson. So today we are going to talk about direct and inverse variation involving quadratics. When you do inverse and direct variation, especially if you go into the science fields, the engineering fields, or even financial fields, your variation a lot of the time is not going to be just a simple linear. You'll have quadratic, there will be times you'll have cubic, you'll have other stuff involving x or whatever other variable. So it's a good idea to paint a picture of what you could expect. Now here in Algebra 1, the highest we're going to get is quadratic. But as we get into Algebra 2 and beyond, we'll deal with the other aspects of the variable x. But for now, we'll stick with quadratic. You may see something, we'll start with the direct variation part. Y varies directly as x squared. Well, much like you would if y varies directly as x, it's going to be y equals k but times x squared, since it varies directly as x squared. K is your constant of variation. So y equals kx squared, since it varies directly as x squared. So let's get started with some examples here. Let's see. We have y varies directly as x squared. They give you y equals 5 and x equals 5. So you have y equals 5 and x equals 5. Find y when x equals 2. Alright, so we start with y varies directly as x squared. Y equals 5 and x equals 5. Then the last sentence tells you find y when x equals 2. So, like you would with any other variation problem, ignore the last sentence for a minute, pretend it doesn't exist. Focus on the first sentence, y varies directly as x. Which means you're going to come up with the equation y equals k x to the second. That's your equation of direct variation. Now, like before, we want to figure out what that constant of variation is. We want to get that k by itself, so we have to divide the right side by x squared. If we do that, you do in fact get k by itself. But since you've done it to the right side, you got to do it to the left side. So that means you're going to have y over x squared on the other side. So the equation for your constant of variation is going to be k equals y over x squared. Now to find that constant of variation, you're just going to plug in the given values of y and x. So therefore k equals y is 5, so you'll put in 5 for that, over your x to the x value, which was 5, that'd be 5 over 5 squared, which equals 5 over 25, which simplifies to 1/5. So the constant of variation is going to be 1/5. So we found the first piece of the puzzle, the constant of variation is 1/5. Next step, again, form your new equation with the constant of variation. That's going to be y equals that constant of variation of 1/5 times x squared. So the equation of direct variation that you get is y equals 1/5 x squared. So we found the constant of variation. Now we found the equation of direct variation. Last thing we need to do now is focus on the third sentence. Find y when x is 2. So we're solving for y. We don't know that. So we'll say y equals 1/5 times the x value of 2 to the second. Well, we know 2 to the second is 4, so you'll have 1/5 times 4, which simply means that y equals 4/5. So when x equals 2, y equals 4/5. That's what you would get when x equals 2, y equals 4/5. And I got more examples here. All right, let's see. See what I come up with for the next example. It's going to be relatively the same. We'll let y equal 9. We'll let x equal 3. Find y when x is 4. Alright, so this particular problem we have here is y varies directly as x squared. Y equals 9 and x equals 3. Find y when x equals 4. So ignore the last sentence for a minute, just focus on the first sentence. Y varies directly as x squared. So that means, again, it's going to, since it's direct variation, y equals k, that constant of variation, times x squared. That's the equation we set up. But again, first thing we want to do is figure out the constant of variation. We want to get that k by itself, so we have to divide the right side by x squared. If we do that, we get k by itself. But we also have to divide the left side by x squared. If you do that, you'll get y over x squared. So the equation for the constant of variation, k, is equal to y over x squared. Now, all we have to do is to solve for the constant of variation is simply put in the values of y and x. So k equals the y value assigned was 9 over that value of x, which was 3 to the second power. Well, that equals 9 over 9. That means k, your constant of variation, is equal to 1. So your constant of variation, which is the first piece of the puzzle, is 1. Now we need to find the new equation with said constant of variation. Y is going to equal that constant of variation, 1, times your x squared. Well, 1x squared is simply x squared. So we could get away with y equals x squared. Since your coefficient's 1, you could just simply write y equals x squared. That's your equation. So we found the constant of variation. Now we found the equation. Now we need to focus on the last sentence. Find y when x equals 4. So we'll do y is equal to that x, which was 4 to the second power. Well, we know 4 to the second power is 16. So when x equals 4, y equals 16. That would be the answer to that one. All right. Let's see here. 2 more problems of direct variation, then we'll move on to inverse variation. So y, we'll say, will equal 23. We'll make y 23. X will equal 5. This time find x when y equals 30. So it's going to be a little bit different. Now, we start with y varies directly as x squared. Y varies directly as x squared, so that's going to mean y equals k x squared. So that's your first initial equation of variation for direct variation. Now, of course, we want to find said constant. Well, what we have to do is we have to divide the right side by x squared to get that k by itself. If we do that, we get the k by itself. But since you did it to the right side, you got to do it to the left. That would give you k equals y over x squared. So that's the equation for the constant of variation. Now, we need to solve for the constant of variation. All you're going to do is plug in your y and x values. So that would mean k is equal to the y value of 23 over your x squared value of 5 squared, which would equal 23 over 25. So I'm going to suggest from here on out for the rest of this lesson we do decimals. There's going to be a reason for that. 23/25 as a decimal is 0.92. So your constant of variation is going to be 0.92. That's what 23/25 is going to be 9.92. So now we want to rewrite the new equation with that constant of variation. That's going to be y equals that 0.92 x squared. So that's going to be your new equation, y equals 0.92 x squared. Now, we are tasked with finding x when y equals 30. This time they give you the y value, which was 30. You'll set that equal to 0.92 times that x squared. We don't know x. Well, ultimately we want to get the x squared by itself, right? We got to divide both sides by 0.92. We divide the right side by 0.92, you just get x squared by itself. That's going to equal 30 divided by 0.92. Which, let me figure out what that is here. If we round to the nearest one decimal place, which I'm going to, it would be 32.6. So x squared is equal to 32.6, since I'm rounding to one decimal place. Well, we want to solve for x, right? But we have an x squared. If we remember, if you have an x squared or a variable to the second power equal to a number on the right, you have to, of course, take the square root of x squared, which is going to be x, but you got to take the plus and minus the square root of the number on the right, because you actually get two answers for this. So x is actually going to equal both plus and minus the square root of 32.6. So if we go ahead and run that real quick, we'll still have the plus and minus. Now let's take the square root of 32.6. Square root of 32.6 to one decimal place rounds to about 5.7. So the answer for x, you actually get two answers when y equals 30. X is equal to plus or minus 5.7. Because you took the square root of 32.6, you had to take both plus and minus the square root of 32.6. So that's the problem with quadratic ones. I'll do one more of direct variation, then we'll move on to the inverse variation. All right. Last one of direct variation. let's see. We'll make y equal to 1 and x equal to 6. So y will equal 1, x will equal 6. We'll find x when y is 7. Okay. So in this equation, we have y varies directly as x squared. Start with that. Y varies directly as x squared means y equals k x squared. Well, of course, we want to get that k by itself because we want to solve for the constant of variation. So we have to divide the right side by x squared. If we do that, we get k by itself. But we have to divide the left side by x squared. You'll get k equals y over x squared. Now to solve for the constant of variation, all we have to do is plug the y and x values in. K would equal, the y value given was 1, over the x squared, which would be 6 squared, which would equal 1/36. So we're going to round the result to, let's see here, how many decimal places is 1/36? Yeah, let's round that to 2 decimal places. K is approximately equal to 0.03. So your constant of variation is approximately 0.03. That's what you would get for a decimal. So you found your constant of variation. Now you need to find your new equation. That's going to be y is equal to 0.03 x to the second. So that would be your equation of direct variation, y equals 0.03 x to the second. So now we found our constant of variation, we found the equation of direct variation. Now we got to find x when y equals 7. So again, we're given the y value of 7. That's going to equal 0.03 x squared. Well, ultimately we want to get that x squared by itself, right? So we got to divide both sides by 0.03. You divide x squared by 0.03, you get x squared by itself. That'll equal 7 divided by 0.03. So 7 divided by 0.03 to 1 decimal place is about 233.3. So you have x squared is equal to 233.3 if we're rounding it to 1 decimal place. Well, that's great, we have x squared, but we want to just solve for x, right? So since we have x squared, we got to take the square root of x squared, which is x. That'll be equal to, since it's to the second power, you got to take plus or minus the square root of 233.3. And now we'll just take that result to 1 decimal place and we'll get our answer. So the square root of 233.3 to 1 decimal place is about 15.3. So the answer is, in this case, when y equals 7, x is equal to plus or minus 15.3. Okay, so now we have done direct variation problems. Let's move on to a few inverse variation problems. All right. Let's see. Let's set up a sample here. Y varies inversely as x squared. So this time we have y varies inversely as x squared. Well, if we recall from inverse variation in yesterday's lesson, that's just going to mean y equals k over x squared this time. Instead of k over x, it'll be k over x squared. So you'll have, for inverse variation, y equals k over x squared. So it works like the inverse variation we've done so far, only x is to the second power. Really not any different, just now you have quadratic to deal with, which, as we saw in the past couple problems, can make your life a bit of a pain. But let's do 4 problems now with inverse variation. Y varies inversely as x squared. They give you y equals 2 and x equals 3. Find y when x equals 2. All right. So we have y varies inversely as x squared. Start with that sentence. Y varies inversely as x squared. So that's going to look like y equals k, that constant of variation, divided by x squared. Well, first thing you want to do again is set up, you want to get your constant of variation. Well, you have k divided by x squared, you need to multiply the right side by x squared to get k by itself. If we do that, we do in fact get k by itself. But what you do to the right, you got to do to the left. If you multiply the left side by x squared, you'll get x squared y. So k equals x squared y. That is the equation for your constant of variation. Now to solve for the constant of variation, just plug your x and y values in. K will equal that x value of 3 to the second power times your y value of 2. Well, we know 3 to the second power is 9, so you'll take 9 times 2, which means your constant of variation k is 18. So the constant of variation k is 18. Now we need to write the new equation with that constant of variation. That means y is going to equal 18 over x squared. That would be your new equation of inverse variation. Y would equal 18 over x squared. Last part, find y when x equals 2. Well, this won't be so bad. All we have to do, we don't know y yet, that's okay. Y equals 18 over that x value of 2 to the second power, which happens to mean it equals 18 over 4, which you could leave it as 9 halves, but we're going to stick with decimals for the rest of the lesson. So that means y equals 4.5. So when x equals 2, y equals 4.5. That's the answer you would get. And I got more. All right, let's see. This time we're going to give y equals 7 and x equals 5 find y when x equals 6. So we'll start with the first sentence of the equation. Y varies inversely as x squared. So all that's going to be is you'll have y varies inversely as x squared, so y equals k over x squared. That's how y varies inversely as x squared. Well, first thing we want to do is find our constant of variation. So we got to get the k by itself. Well, we have k divided by x squared. That means we need to multiply the right side by x squared to get k by itself. If we do that, we do get k by itself. But that means you got to multiply the left side by x squared. If you do that, you get k equals x squared y. That would be the equation for your constant of variation. Now all that's left is to find your constant of variation. You plug in your values of x and y. So k is going to equal, your x value is 5, so you'll take 5 to the second power times your y value of 7, which means k equals 25 times 7, which should mean that your constant of variation k equals 175. So your constant of variation k is going to be 175. So that's one piece of the puzzle. Now we need to find the equation of inverse variation. That's just simply going to be y equals 175 over x to the second power. So your new equation of inverse variation is y equals 175 over x to the second power. Now the last component of this problem is find y when x equals 6. Well, all we got to do, y equals 175 over that x value of 6 to the second power, which would have to mean it's 175 divided by 36. So we'll round the result to 1 decimal place. We'll take 175 divided by 36. That to 1 decimal place gives you about 4.9. So when x equals 6, y is about 4.9. That would be the answer you get. I have 2 more problems, but we're going to switch it up a little bit like we did with the direct variation. All right. Let's see, y equals 2. X will equal 3. This time we'll find x when y equals 3. All right. So let's start with the first sentence of the problem. Y varies inversely as x squared. So again, that's going to be y equals k over x squared. Well, first thing we want to do is solve for that constant of variation. We got to get k by itself. So that means we got to multiply the right side by x squared. If we do that, you get k by itself. That's going to be equal to what you got to do. What you do to the right side, you have to do to the left. You have to multiply the left by x squared. So you'll get k equals x squared y. That would be the answer you get, k equals x squared y. Now to solve for the constant of variation, all you have to do is put in the initial values of y and x that you were given. So k equals, let's see, x squared, that'd be 3 squared, times your y value of 2, All right. So then you get k equals 9 times 2, which means your constant of variation k is 18. So your constant of variation for k is 18. So that's one piece of the puzzle. Next piece is find the new equation with that constant of variation. You'll get y equals 18 over x squared. So the equation of inverse variation is y equals 18 over x squared. Now there's one more piece to this problem. They want you to find x when y equals 3. So let's find x when y equals 3. So what you're going to have to do is we know y equals 3, so you'll get 3 equals 18 divided by x squared. Well, we want to ultimately get x squared by itself. Of course, we have to get it out of the denominator and out of the right-hand side, which means you have to multiply both sides by x squared. You multiply the right side by x squared, you get 18. That'll be equal to, you got to multiply the left side by x squared, you'll get 3x squared. So now you have 18 equals 3x squared. Well, we want to get the x squared by itself, so you have to divide both sides by 3. If you divide the right side by 3, you just get x squared by itself, which means you got to divide the left side by 3. 18 divided by 3 is 6. Well, we have x squared equals 6. We want to just solve for x. So of course, take your square root of x squared, which will just give you x. On the right hand side, you got to take both plus and minus the square root of 6, which if we round this to 1 decimal place, which is what we're going to do, let's find the square root of 6. Rounds to approximately 2.4. So when y equals 3, x equals plus or minus 2.4. You get two solutions since x is a quadratic in this case. And I got one more. Just one more problem, then we're done for the day. Alright, let's see here. What are we going to do with this last problem? We'll make y8. We'll make x9. Find x when y equals 5. Okay, so to start with this problem, y varies inversely as x squared. So let's start that part first. Y varies inversely as x squared means y equals k over x squared. Well, we want to solve for that constant of variation k, get it by itself, so we got to multiply the right side by x squared. If we do that, we get the k by itself. But what you do to one side, you got to do to the other, so you have to multiply that y by x squared. You'll get x squared y. So k equals x squared y. Now all we got to do is solve for that constant of variation, is plug in your values of x and y and solve. So k equals your initial value of x was 9, so that'll be 9 to the second power times your y value of 8. Well, we know 9 to the second, that's 81, so you'll take 81 times 8. You're going to have a huge value for the constant of variation. So let's see, we'll have 81 times 8, yep. So your constant of variation, k, is going to end up being 648. that would be the answer for your constant of variation. K equals 648. So now that you found that piece of the puzzle, you can find your new equation of inverse variation. That'll be y equals 648 over x to the second. That is your equation of inverse variation, is y equals 648 over x to the second. So we found those two pieces of the puzzle. There's one last piece. We need to find x when y equals 5. So this time they give you y equals 5, so you'll put in 5 for where y is. That'll equal 648 divided by x squared. We don't know what the x is, but we ultimately want to get x squared by itself. First thing we got to do is get it out of the denominator and out of the right hand side. So you multiply the right side by x squared. If you do that, you get 648. That'll be equal to, you got to multiply the left side by x squared. You get 5x squared. So now you have 648 equals 5x squared. Ultimately, we want to get that x squared by itself. You got to divide both sides by 5. You divide the 5x squared by 5, you just get x squared by itself. So now we got to take that 648 divided by 5. I'm going to round the result to one decimal place. 648 divided by 5 is 129.6. So you get x to the second equals 129.6. Well, there's just one problem. We have x to the second. We need to just find x. So once again, you're going to take the square root of x squared, which will give you x. That'll equal, since it's a square root, it'll be plus or minus, plus and minus, the square root of 129.6. Which now we're going to round to the nearest decimal place. X will equal plus and minus whatever that value is for the square root of 129.6. Square root of 129.6 comes out to about 11.4. So when y equals 5, x is approximately equal to both plus and minus 11.4. Because x was initially to the second power, that's why we have two answers for x. X equals plus and minus 11.4. So that's been it for direct and inverse variation with quadratics. Next lesson will be our final lesson in the variations unit. We will be talking about joint and combined variation. So stay tuned for that. Hope everybody has a good night. Take care.